Welcome to the Introduction to Networking course. In this course, we'll cover the basics of networking. We'll start with what is a network and why it's needed. Next, we'll describe the network components and provide the requirements for a networking solution, especially in highly demanding environments. Lastly, we'll introduce the OSI model and the TCP/IP protocol suite and their role in networking. We have a lot to cover, so let's start. A network is a collection of nodes connected together so that they can exchange data such as voice, video, storage, or management. Applications running in modern data centers have unique performance requirements. The network must be able to provide the performance expected by the running applications, such as high bandwidth and low latency. In addition, the network must be highly available and scalable to support future growth. This is not an easy task. So, how do we create a network? Network components include the end nodes and intermediate nodes. The end nodes include compute, storage, and management nodes. These are the source or destination of the traffic carried in the network. The intermediate nodes, such as switches and routers, receive the traffic generated by the end nodes and make decisions as to where the traffic should be forwarded. Let's see how a simple network is formed. Every end node has a network interface card, or NIC. The NIC is a hardware component that resides in a slot and has one or more network ports. The next step would be plugging a cable into the NIC port on one end and into a switch port on the other end. Great! Now we have the end nodes physically connected. But how do they communicate? For the end nodes to be able to communicate with each other, an example sending and receiving traffic, they must implement the same communication protocols, where each protocol is responsible for a specific set of activities. Each protocol defines a set of communication rules, such as how the communication session is set up and terminated, what is the message format, and how errors are handled. There are many protocols for different purposes, and we are not going to cover them all. A group of protocols that run concurrently to implement network communication is called a protocol suite. Different protocol suites are different combinations of protocols that are used for different communication types. Later, we'll introduce the main protocol suites used in today's networking deployments. Considering all the hard work that a network is expected to do, it is easier to break down the different functionalities of network communication into layers, in order to make communication easier. The Open Systems Interconnection, OSI, is an ISO standard model that describes 7 layers that computer systems use to communicate over a network. It is a generic, protocol-independent standard that was the first standard model for network communications adopted by all major computer and telecommunication companies in the early 1980s. If you've heard already about a Layer 2 device such as a switch or a Layer 3 protocol such as IP, they all refer to the respective OSI layer. We'll cover some of those later. There are many advantages to a layered model. Some are listed here. Another networking-related model is TCP/IP. The TCP/IP model is, in a way, an implementation of the OSI model, since it's provided with a suite of protocols that enable end-to-end data communication services. When comparing the two models, we see that TCP/IP, the physical and data link, are both combined as a network access layer. Also, there is no session or presentation layer in the TCP/IP model, so the 3 upper OSI layers are combined into a single application layer. In the 1970s, the US Department of Defense developed a network called ARPANET that enables data transport between computers at different locations by creating alternate routes. TCP/IP was used as the system protocol for that network. ARPANET ceased to exist in 1990, but since then, TCP/IP has evolved to meet the changing requirements of the Internet. TCP/IP specifically defines how computers should be connected to the Internet and how data can be transmitted between them. TCP/IP protocol suite is named after 2 of the main protocols: TCP, Transmission Controlled Protocol, and IP, Internet Protocol. The TCP/IP suite is a set of communications protocols used on the Internet. It includes protocols that specify how data is packetized, addressed, transmitted, routed, and received, thus providing end-to-end data communication. Shown here are some of the protocols in the suite, where each protocol is listed at their respective layer. Please note that TCP/IP model has 4 layers as opposed to the 7-layer OSI model. Layers of the different protocols should always be referenced to the OSI model. For example, the Internet Layer protocols, IP version 4 and IP version 6, are considered Layer 3. Similarly, the Transport Layer protocols, TCP and UDP, are considered Layer 4 protocols, and Application Layer protocols such as HTTP and FTP are referred to as Layer 7 protocols. We'll cover some of these protocols in more details in the following units. In order to understand how data is transmitted between applications, it's important to understand what encapsulation is. Sending application creates messages that are passed to a production line of the lower layers, where each layer adds its relevant information in a process known as encapsulating the data with a layer header. Header is the supplemental data placed at the beginning of a block of data when it is transmitted. The supplemental data is used at the receiving side to extract the data from the encapsulated data packet. This packing of data at each layer is known as data encapsulation. By the end of the encapsulation process, the encapsulated data is transmitted on the wire. Each layer is associated with different protocols: PDUs, protocol data units, addresses, and devices. Let's see these for each of the layers. The data generated at the application layer for network transmission is referred to as a message. A message is then encapsulated at its lower layer, the transport layer. The transport layer adds a layer 4 header that includes fields such as port numbers that are relevant for transport layer processing at the receiving nodes. A message encapsulated with a layer 4 header is called a TCP segment or a UDP datagram. These are the layer 4 PDUs. A TCP segment or a UPD datagram is handed over to the internet layer and is further encapsulated with the layer 3 header, containing, for example, source and destination IP addresses. The layer 3 PDUs are called packets. Packets are routed in the network by layer 3 devices called routers. Packets are then passed down to the data link layer that adds a layer 2 header. Layer 2 PDUs are called frames. The most important values in the data link layer header are source and destination MAC addresses. Frames are forwarded in the local network by layer 2 devices called switches. The frame is then transferred to the physical layer, layer 1, and is converted into a stream of bits. The stream of bits is then placed on the network medium for transmission. We've used many technical terms to describe the flow of data transmission. No worries if you're not familiar with some. We'll cover them in more details later. At this point, it's only important that you understand the general flow. Throughout the course, we'll use standard icons to represent typical network components. Please take the time to review them and make sure you are familiar with them.